All right. Let's hope this kind of an awkward angle this time around, but I think that'll work. All right.
What are you doing?
Huh?
Brendan.
Recording it for Brendan because you know
Recording it for Brendan.
2 broken arms.
Yeah. All right.
Skiing.
Okay, everybody. So, today what we're going to be up to is we're going to be finishing talking about partial fraction decomposition, and then also moving on to some new topics. A lot of what we're going to be doing today is going to seem kind of a little off at first, or rather, the subjects in the next week or so are going to seem to not have much to do with each other, and at the end they're all going to come together. Okay. So it is going to be rather, so do note we are skipping around a bit.
You go okay. Tomorrow, 5 minutes?
Yeah, it's like tomorrow in class there'll be a very brief, like really 5-minute quiz on partial fraction decomposition. Basically, it's one problem just to make sure you guys got the idea down how to do it. Okay, nothing out of the ordinary, all right? And it's not that complex of a problem. Okay? Cool. All right. To start off with, let's go ahead and look at. Let's wrap everything up by doing a few of the homework problems. Excuse me. Okay. To start off with, I want to do 62, which was the last one from the first set of exercises, and then 71 and maybe 73. We'll take a look at those. The reason I want to start with 62 is just to give you an idea of how it works, but also to just kind of tie in with the rest of the lesson after we're done doing the partial fraction problems. Okay? So basically, number 62 here, okay? We've got 6x plus 5 over, okay, x plus 2 to the 4th, okay? Now, everybody, what's going on here? How would I divide this into, with partial fractions? What would my fractions look like?
A over x plus 2.
Okay.
B over x plus 2 squared.
Good. And then so on and so forth until I reach x to the 4th. Yeah. So there's actually going to be 4 fractions here. There's going to be a times a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed plus d over x plus 2 to the 4th. Everyone see how that works? All right, good. Now, this one's going to be a little bit, when we actually dig this out to solve for A, B, C, and D, we're going to see this one does something a little different than what we've been used to in the past, okay? First thing is we set it up quite normally. It's going to be 6x plus 5 equals A, and what am I going to multiply A by? Not x plus 2 to the 4th, close. X plus 2 to the 3rd. The reason why it's to the 3rd is because remember there is, or it has as its own denominator an x plus 2. So it will cancel out one of the ones from the 4th. So this would be x plus 2 cubed. How about B? What's it going to be? To the 2nd. So x plus 2 to the 2nd. Good. How about C?
X plus 2.
X plus 2. And finally, D will just be by itself on the end. Okay? Alright, now we're not going to solve this one out fully, but we are going to kind of begin to set it up. And the reason why is because I want to show you what happens. And this sometimes often happens with a lot of these partial fraction problems. If we were solving this, what number, obviously, would we choose first for x? Negative 2, because that's going to cancel everything out except for D. So when x equals negative 2, we're going to have 6 times negative 2 plus 5 equals, A is going to cancel because we'll have 0, B will cancel because again it's 0, C will cancel because it's 0, and D will be all that's left. So it'll just be equal to D, which then gives us minus 12 plus 5 equals D. So D then is negative 7. Okay? So nothing too bad there. But now what? What x can I pick that will let me solve for a?
Negative 2.
You pick up.
Well, if I pick negative 2, I get rid of a.
Yes.
And I want to live with d. Is there an x I can pick?
No.
No. Okay? So basically, I'm not stuck here, but to figure out what a, b, and c are, I'm going to have to basically choose random x's, copy down the result, then choose another random x, copy down the result, then choose a third random x, copy down the result. So then I set this up as a multivariable equation, okay? With three unknowns, okay? Basically a, b, and c being my unknowns. So generally speaking, whenever you have to do that, you want to choose the easiest x's possible. Those three numbers are usually 0, 1, and negative 1, okay? And you can choose those three as long as you haven't already used them. We haven't yet, so we'll make x equals 0 first. When x is 0, this thing is going to be 5 equals a times 2 cubed plus b times 2 squared plus c times 2 minus 7. Because remember, we know that d is negative 7, okay? So that's my first equation. Then I do the same thing, this time when x is equal to 1. When x is equal to 1, I'll have 6 times 1 plus 5, so that's 11, equals, okay, a times 1 plus 2 cubed, so it'd be a times 3 cubed, plus b times 3 squared, plus c times 3 minus 7, okay? And then I'll do the same exact thing, but this time with x equals to negative 1. And that'll be negative 6 plus 5, which gives me negative 1, equals a times 1 cubed plus b times 1 squared plus c times 1 minus 7. Okay, now I've got three equations with three unknowns. I can solve this, okay? But this is no longer a partial fraction decomposition problem. This is now just a standard solving this multivariable equation, okay? So if you guys remember from Algebra 2 or Algebra 1 even, doing multivariable equations, that's all this became here at this point. Figure out what A, B, and C are, okay? So you can figure this out with substitution or elimination or...
Take a while.
It would take a while because it's three equations with three unknowns, okay? And that's going to tie into what we're going to be up to next after partial fractions. We're basically building up to find a way to solve a multivariable equation like this very quickly, okay? And not do it by hand, to be able to use a calculator or a computer to do it, okay? And we're going to begin working towards that end today. All right, everyone got that? But it's going to take some setup to get us there. All right, but this is as far as we'll go with this problem here. Any questions? Nope. All right. You didn't know you were going to get a song and dance in that class, did you? All right. Okay, let's take a look at two of the examples from the last set of homework problems, okay, from last night. So let's look at 71 first. Okay. Now, 71 actually, it looks terrible. It's actually not that bad at all. So 71 is x squared plus 12x plus 12 all over x cubed minus 4x. All right, so I'm going to split this up into fractions. What do I need to do first, though, before I do so? Factor this denominator. So what's it factored to? Anybody know?
X times x squared minus 4. Right?
Okay. So immediately it goes to x times x squared minus 4. X squared minus 4. What does that factor to?
X plus 2x minus 2.
X plus 2x minus 2. So we'll have x times x plus 2, x minus 2. Okay? So now setting this all up into fractions, we're going to have a over x plus b over x plus 2 plus c over x minus 2. Okay? Any questions about the setup there? Probably straightforward, right? All right, good stuff. Now, if you remember yesterday, okay, I said whenever we had non-repeating linear factors, there was kind of a quicker way to set up, to solve for A, B, and C. This is an example of how that quicker way would work, okay? Really all you have to do to solve for A, B, and C, the setup for that, is one, just go ahead and write the numerator of the original fraction. Okay? And set it equal to A times a bunch of stuff, B times a bunch of stuff, C times a bunch of stuff. When we do that next step, you're going to choose the denominators that are not under the letter you have. So for A here, I'm going to multiply it by the other two denominators, x plus 2 and x minus 2. Okay? Okay? With B, same deal. Its denominator is x plus 2, so I'm going to multiply B down here by the other denominators. Okay? And in C, I will do the same thing with it. Okay? Alright, and so now, we've got everything set up and ready to be solved. Okay? Any questions so far? Pretty straightforward. Notice how you can do that really fast. That's because of the fact of how these things work. Okay? We don't have to do that multiplication step out over and over and over again. Okay? That's why it's nice when you have non-repeating linear factors. Okay? At this point, this solves exactly like the other ones did. You're going to pick an x, and you're going to pick an x that cancels as much stuff out as you need to, okay? Or can. So, excuse me, what's the first easiest x to pick?
2.
Okay, 2 works nicely.
0.
0 would work, and so would, what's the last x?
-2.
-2. Any of those 3 numbers would work and be good answers. Let's start off with 0, simply because 0 is always a good number to start off with. Okay, when x is 0, if I chose x to be 0, I'm going to get rid of B, I'm going to get rid of C. Okay? Anytime you have a 0 appear in any of these things, okay, once a 0 is in there with multiplication, everything goes to 0 and we're done, okay, with that term. So, kind of writing this out here, we'll have 0 squared, which is 0, plus 12 times 0, which is 0, plus 12, so it's going to be 12, is equal to A. 0 plus 2, so it's just 2, times 0 minus 2, which is minus 2. So, the setup, when x is 0, this is what we're going to have. 12 equals A times 2 times -2, which is really 12 equals -4A. So, A is going to be equal to -3. Okay? Any questions there? Good. We're going to do the same thing. Next one we'll pick positive 2. When x is positive 2, I'm going to get rid of A, and I'm going to get rid of B, and just solve for C here at the end. Okay? So, doing it that way, I'm going to have 2 squared. Whoops, let's make that look more like a 2 squared. Plus 12 times 2, plus 12. A is going to disappear, B is going to disappear. Going to be left with C, so it'll be C times 2 times 2 plus 2. Okay? Now we just work this out. So this is going to be 4 plus 24 plus 12 is equal to C times 2 times 4. That's going to give us, let's see, 3640 equals 8C. So C is going to be equal to 5. Okay. By the way, everybody, this is why you bring a calculator, because calculator can clean that up nice and quickly for you. Okay? Do the same exact thing with minus 2x, or x equal to minus 2. Okay? That's going to give us minus 2 squared, which is 4, plus, minus 2, or times, plus 12 times minus 2, which is negative 24. Okay? Let's make this clearer. 4 minus 24, plus 12. Okay, and then A cancels, C cancels, and I'm left with solving for B. So that's going to be B times -2 times -4. Okay, clean that up here.